All right, let's dig a little bit deeper. So if you haven't seen the first video yet, I recommend you go take a look at it. It's short and it really is a bit of a surface level, but it gives you some of the backstory as to why I'm doing what I'm doing here. But for now, I'm gonna talk about some of the issues and challenges I see with I guess typical lighting. So Exhibit A, we're gonna go for the first one. Most rooms, this one included, my home office, it's got typically a single light bulb to illuminate the whole room, and it's often right in the center. Now, if you want to, it's going to be tough. You're going to have to step back a little bit if you want to see this. A little more. Perfect. Look at this. So this entire room, this is my home office. You're looking at a little bit of a bigger view of it now. But this light right here is actually in the center of the room. And this is the light that's supposed to illuminate the entire room. Now, of course, I'm doing some filming here, so I got a whole bunch of extra lighting in here just so it looks a little bit better. So, you can see the room fairly clearly. But normally, this is the one light that's supposed to illuminate everything. Uh, you know, it's functional, but we can do a lot better. Okay, I'm guessing you've seen this before, right? I mean, most of the homes that I've seen, they're kind of the same. One light illuminate the entire room. We know we need some more lights here because that single light, it casts shadows, it creates unevenness throughout the whole room, and it doesn't do the room any justice. So, what most of us do is we put lamps everywhere, right? Extra lamps, but now we got wires running all over the place. And not only that, each and every one of those lamps requires, you to turn it on. Now, sometimes we're creative and we'll take those lamps and we'll run all the cords into one extension cord and then have that one, switch that turns on all the lamps or something. But we still have this other light here, the central light that's got to be flicked on from the switch on the wall. It gets a little overly complicated, right? And so, it's a hack. It works by putting extra lighting in, but there's got to be a better way. Now, sometimes in some rooms, there's actually more than one light, right? And the most common example of this is those downlights. Take a look at my bathroom.
Okay, so here we are in my bathroom. I know the acoustics are terrible in here, but then again, it is a bathroom and you're not really supposed to be filming in here. So, anyways, here we are. We can see the downlights, right? These are, I mean, I'm sure you can see on the camera, there's probably about three at least, but there's actually about six in here. It's a fairly small room, but with them pointed down, it illuminates the room quite well. So you certainly get a lot more illumination with these kind of downlights, but there are a couple of challenges, right? First of all, if you're follically challenged like me, it creates some glare and shininess and unpleasantness, so my apologies. Secondly, you don't want to look straight up into them, right? Because they're fairly bright. They're kind of like point light sources, and when you stare into them or even glance into them, they're pretty sharp and it can hurt your eyes. So you generally don't want to be looking up.
Downlights, pot lights, whatever you want to call them, they're clearly more effective at illuminating the room. They've been more effective at illuminating rooms for decades, right? They're not new. They've been around for years. You probably have them all over your house. I certainly do. I certainly have some in my bathroom that you just saw. There were six of them in that small room. In larger rooms, you might have a dozen or even more pot lights or downlights within a room to illuminate it, and they're quite effective. But just like in my bathroom, and also in the office, the single central light in my office right here, it's either on or off. And I don't know about you, but going into that bathroom and flicking the light on, they turn on so fast and it's so sharp that it kind of hurts, right? So I don't know. I think I prefer dimmable lights. I prefer lights that maybe slowly turn on, or I can adjust the intensity of them. And I mean, that's fairly simple to do. You can go buy dimmable lights or get that little knob that controls them. But I don't. I mean, I don't have them in my bathroom. I don't have it in this room. I think all lights should be dimmable.
What the heck is this? Four switches. Do we really need four? I got these things all over the house. Here, here, and here. What the heck is this round one?
It's all so confusing. So many switches. I mean, I've been living in this house for years, and even now, I'm still wondering, is that the switch to push or is that the switch to push? And if I'm the one confused, I mean, can you imagine if guests are coming over? They would have no clue which switch is the right one to turn on. So here I am on one side saying that, we need to have more lights or more ability to illuminate the room. So you'd want to have some more control. But if you have more lights, you're going to need more switches to turn on the individual lights, right? There's got to be a better way to be able to control a larger amount of lights individually, but still simplify the switch mechanism or the user interface, if you want to call it, right? There's got to be a way to simplify it while still having more lights in the room. We'll figure that one out as we move forward.
Oh, and here's a fun one. 3-way switches. Watch this. Light turns on. Let's go upstairs. Same light, different switch. Look, I got one here too.
So these 3-way switches, fantastic, right? They're really effective. I mean, that earlier scene you saw in my hallway, that hallway leads to the bedroom. So you can imagine, waking up in the middle of the night and you need some light. Well, the switch is right by the doors to the bedroom, so you can turn it off. Or when you're coming home, perhaps late at night, you want to get to the bedrooms, the hallway's dark, so the switch is at the opposite end. You can flick the switch on and turn the light on. Brilliant. 3-way switches are great. But I have a little problem with them. I don't know. I'll let you decide if it's too much.
Okay, so you remember when I went upstairs, I turned the light off. Here's that same switch, but it looks like it's pointed up, suggesting to me that the light should be on. So now if I flick it down, the light turns on. So the 3-way switch is working, but this is backwards, and it irritates me.
What do you think? Is that too much? I don't know. It bugs me, and I don't know. I feel like it's the little things that will eventually drive you insane. Anyway, okay, on to other things, right? What about this? What about when you're ready to watch a movie, you get all cozy and comfy on the couch, you got your pajamas on, you got your snacks with you, and then you forgot to turn the light off. Oh, gosh. Gotta get up, turn the light off. That's, say the least, that's annoying, right? So, sometimes switches aren't often in the best place. So I've heard there's a way you can deal with this, right? It's the Wi-Fi enabled switches. That's kind of cool, right? So you actually have an app on your phone to be able to turn on and off the switches. I've seen these bulbs in the stores. I don't know about you, but I lose my phone like 100 times a day. Speaking of which, I don't know where it is right now. Hold on. It's got to be around here. Oh. Of course. Happens all the time, right? So, I mean, the idea of having a Wi-Fi controlled phone is great until you can't find your phone. And I don't know, even if you did have your phone on you, right? It's like, I got to first locate the phone and then turn it on, find the app, and then, find the right setting and shut it off. I guess, I don't know. I guess it's kind of gimmicky to me, really. I think for the most part, you're going to want to have a switch. And then there are these internet connected lights. I know you can do that, right? So what's the theory behind that? If you're coming home from a drive and you want to be able to turn your lights on, you can do it from the car. I guess, but most of the time when I need to turn a light on in the room, I'm usually right there. Unless, of course, I'm sitting on the couch and I don't want to get up. Okay, so maybe there's a case for Wi-Fi connected lights or something that you can control on the phone, but that's got to be an option. You still need to have a physical switch because that's where everybody else who doesn't have their phone is going to be able to control the lights, and it's ergonomically friendly, so you're going to want to have a switch. Wi-Fi connected from an app, secondary option. I can't believe I nearly forgot about the home automation kits or the smart home kits that you can buy at stores these days. These things are pretty cool, right? I mean, they connect to your home automation, I guess, network, maybe. I don't have one at home. Actually, that's why I actually don't know a lot about how these things work, but they are becoming more prevalent, right? So the example I shared earlier, where you're kind of sitting down on the couch, all comfy, ready to watch a movie, and you forget to turn the light off. So it would be nice to be able to just simply speak and let the home automation kit, interpret your voice and then turn off the lights or dim the lights accordingly. That would be pretty nice if you just spoke and it listened to you. So there's a case to be made here. I'll have to admit that if we were to integrate, perhaps, to some of the home automation kits that are out there on the market today, it would add a nice little value. But I mean, it's a bit complicated, and I would argue that we're probably still a bit too early for that. But even then, I'm still going to stand firm on the original point that we need to have a switch. All of this Wi-Fi connected or internet or even the home automation, these are all nice to haves, which we'll evaluate later on as we get into this. But without a switch on the wall, this thing is not going to be ergonomically friendly. So we're going to start with a switch. I strongly believe that we need to have a proper control system that you can physically, with your hands, interact with. So all that other stuff, nice to have, we'll work on it later. We're going to start with the switch on the wall. Okay, so by now you've undoubtedly heard of LED lights, right? I mean, they've taken over the market, and where I live in Canada, it's actually harder to buy the older incandescent lights from stores. It's actually LEDs are ubiquitous now everywhere. So I have an older incandescent style bulb here and an LED bulb here. So they are different, very different in fact. These incandescent light bulbs, if you look inside, there's a little filament, right, that the energy actually runs through, and it's through that filament it actually gets hot and it burns, if you didn't know how incandescent lights work. So when it burns, it actually gets quite hot. As you know, you don't want to touch a bulb, but it also gives off light, right? So they're quite wasteful when it comes to energy usage. This one, I don't actually know how much energy this thing uses, but I'm going to guess it's probably a 40-watt bulb. And then this one over here, this is an LED bulb, and this is, I think, it might be a 60-watt equivalent, so it's not actually 60 watts. I think this uses about 10 watts, so it's a lot less than this, a quarter of the energy that this thing uses, and it's probably just as bright, if not brighter, right? So these things, of course, are very different. They look a lot like the regular bulbs. You can just plug them into your regular sockets, but I popped one open. Here's one that I've opened up a while ago. Here it is. Okay, so it's the same one, but it's open, and you can kind of see it looks very different inside. There's a whole bunch of tiny LEDs that are lit up with this thing. The other thing that's different about it is the way that the electronics work. So if I pop the bottom off and look inside, there's all sorts of little electronics in here that allow this thing to work. So in my next video, I'm going to go into the details of the differences between the way that incandescent lights are driven and the LEDs are driven. But for now, suffice it to say, they're different. And so, but they still, the plug, look at the bottom here, the plug still means that they still fit into the regular household lighting sockets, right? And they've been designed that way. So you can go out, you can basically get rid of these and swap it with these LED bulbs, and it'll just fit right into your home. And by the way, if you haven't done that yet, shame, right? You should not have any of these in your house. They're very wasteful and very environmentally unfriendly. So get rid of these if you can. But we're going to go into a little bit more detail as to how these things are different in the next video. But like I said before, they plug into the same outlet, and they're driven differently, right? Incandescent light bulbs are driven very different than LED light bulbs. The electronics required to run them exist, and they're quite different. And so what's actually happening in here is that deep inside here is that 120 volt alternating current coming out of your wall actually is being turned into a direct current. Okay, that may need a little bit of explanation. The alternating current that's coming out of the wall socket at home, it kind of looks like this, right? It's this movement of electrons or energy delivery that happens both in forward and backwards direction, hence the word alternating. It's alternating between pushing and pulling. And so you get this kind of like wave formation that comes out of the wall, and it happens really fast. Depending on where you live, this little wave can happen at either 60 times a second or 50 times a second. Regardless, it's fast, but it's moving in both forward and backward direction, hence alternating. These kind of incandescent light bulbs, they don't care whether the energy flows through them forward or reverse. They're going to light up regardless. And because it happens so fast, that little filament inside doesn't have the time to cool down or start to dim away. And as a result, you get a nice, bright, consistent light on both the forward and backward motion. So these incandescent bulbs are happy with this kind of energy transfer. LED bulbs, on the other hand, they are not very happy with this kind of alternating current. In order for them to work, they need a direct current, which is not both forward and back. It can only deliver energy in the forward motion. And so this electronic wizardry that's happening at the base of every single one of these bulbs, there's a lot going on. And like I said, I'm not going to get into the details, but it takes this waveform and it transforms it in a couple of different phases. So one of the first things that it does, it takes the first half or the top half, the element that's pushing the energy in, and it keeps it. Then it takes the bottom half and it flips it so that it also becomes an energy delivery mechanism. And so what we end up with is these two pulses of energy, both in the forward direction. That's still not quite good enough, because the next thing it needs to do, it needs to smooth it out. And so through a little bit of other electronic wizardry, it takes those peaks and it smooths it out into this nice green line that you see here in front of you. And that green line is going up, but it's going to stabilize. In fact, if I zoom out a little bit and look at this in a larger period of time, you're going to see that that green line, let me get rid of the other squigglies because it gets a little bit messy here, stabilizes in a nice, consistent, direct current form. Now, this energy transfer, these LED bulbs are much more happy to deal with. In fact, they need a direct current like what you're seeing now for them to even work. So this conversion from alternating current to direct current happens inside each and every one of these store-bought LEDs. It has to happen because that's the way the LEDs work. But whenever you do a conversion like this, there's always some type of wastage, energy waste that's happening. And I guess we can get pretty good. I mean, the wastage is probably minimal depending on the components that you use. So some manufacturers will have better components than others, and as a result, will waste less energy. And I'm sure there's lots of different LED manufacturers out there, and some of them will cheap out on components and give a poor quality conversion, therefore wasting more energy. Others will do better. But still, it has to happen at every single one of these bulbs. And I feel like there's a better way to deal with this. Perhaps there may be a way to do the conversion earlier on in the system, and then perhaps distribute the direct current to lots of different bulbs in the house. There's got to be a way to do that. We're going to research that and maybe dive into that a little bit more later on. But for now, suffice it to say, there are ways that we can improve this system, I think. Still, it's been done this way for a reason. That's the other thing. It's been done this way because you can take those components, you can stuff them inside here, and then make it so that the connector looks just like the connector that you already have. So really what we're doing is we're taking some high-tech, electronic wizardry in these LED devices and plugging them into a 100-year-old lighting system in your home. I think we can do better and improve the lighting system in the home, perhaps to save energy and be more effective at distributing lighting. We'll see. Oh, and the other thing that I'm sure you've seen as well is these RGB bulbs, or red, green, and blue bulbs. So in a single bulb, they have multiple colors, and they're often controlled with one of these little remote controls that you can change the color. I don't know, man. I think this also verges on a little bit gimmicky to me. Um, I, I'm not saying that a multicolored light can't be effective. I actually think that if done right, you can get a full RGB or multicolored light installation that, makes the end result could be truly impressive. But that requires a very significant overhaul of your lighting. It's not like you can just take one bulb out, stick one of these RGB bulbs in, and have a good effect. To me, that looks kind of gimmicky. And maybe there's a use for it. I'm not here to judge. I guess maybe I am, but I don't. If you like it, great, use them. I don't think that a single or just a few RGB bulbs are going to be helpful. I think you really need to do an overhaul, which brings me to this point of doing an overhaul. I think at the very least, if you can replace these with these, go for it. But like I said before, we're still operating on this 100-year-old lighting system that's built in the house, and I want to see if we can improve that. So what I want to try to do is improve the underlying system so that we can actually get better lighting throughout the house. And that does mean an overhaul. So I think we're going to have to I don't know. We'll try to do at the lightest touch possible, at least with the development of our lighting system. I don't want to have to, rip apart a house if it's all that unnecessary. Maybe we can do it without ripping apart a house, but I feel like there needs to be a bit of an overhaul done to the lighting system. So, we'll toss some ideas around about how the best way to deal with this is. But fundamentally, I think if we're going to be really changing something, then we got to be ready to do a lighting overhaul. And if we do this lighting overhaul right, then we can start applying some of the other things that we've all heard of. This concept of um, lighting needs to be done in layers, and I touched on this before, right? A single light is rarely good enough to light up a room. You need multiple lights, but those multiple lights need to be done in layers. You've heard of this before, like ambient lighting and task lighting and accent lighting. All of those fancy terms used to describe these different layers. And, I'm going to leave that to the lighting designers. But for our control design perspective, we need to enable enough control so that you can actually do those sort of things and layer your lighting. So we have to be able to provide a layered lighting control system throughout the house. So I think that's going to be really important. So we have to do this kind of overhaul that allows us to do this. And we also want to do it in a modern way. This whole thing about alternating current to DC conversion, we want to try to minimize the amount of times we do that conversion so we can save energy. I think we can be able to do that as well. And the other thing too is, of course, if we make this design so custom and new, then other people or other lighting designers won't be able to plug their lights into it. And that's not going to be effective, right? Because I think we want to make this so that other people can use it as well. So I'm going to have to draw the line somewhere, right? I don't think I'd want to continue designing this system while still using the old style lighting. So I think there's going to have to be a change here. But, we're going to I'd like to make it so that it's non-proprietary. What that means is I'd like to make that system so that although it won't be the same system that we're used to now, I want to be able to make it so that designers and people who actually create these bulbs can do so in a reliable way and plug them in. That way, while we create the control system, the designers and the lighting engineers out there will be able to create some really fancy and cool luminaires or bulbs, whatever you want to call them, to plug in the system, and they'll still work. So we can't make it proprietary. We want to make it open, but it's going to have to be a little bit different. All right. I got a lot of wants. It's a big list. So let's get to it.